So now we are discussing the electrical potential. So the electrical potential is simply defined as the work done per unit charge. So we have calculated in the last lecture that potential V due to the point charge Q at a distance R, this is the distance R, the electric potential is equal to 1 upon 4 pi epsilon naught Q upon R. This is the electrical potential at a point P. This potential is a scalar quantity, so therefore it has a no direction, it has only magnitude. So this is the electrical potential at a point P. So now again we have discussed, instead of this single charge, if we have a multiple charges like that Q1, Q2, Q3, Q4 up to Qn. So there are so many charges which are distributed in a space. तो यहाँ इस चार्जेस की वजह से हमें किसी भी पॉइंट पे अगर पोटेंशियल मालूम करना हो कि एट अ पॉइंट P what is the electric potential due to the sum of all charges, so we can calculate the potential due to the charge first, potential due to the charge second, potential due to the charge third, potential due to the charge fourth, and up to the potential due to the charge n. So here, so we say that this is at a distance r1, this is at a distance r2, this is at a distance r3, this is at a distance r4. So the total potential V can be written as the potential due to the charge Q1, which is equal to V1. The second, the potential due to the charge 2, which is called V2. The potential due to the charge 3, which we call it as a V3, up to the potential due to the all the charges, up to the potential due to charge N. So this is the sum of all the potential at any point due to the sum of all charges. So here the potential is equal to this. If it is 1, the V1 which is due to the charge 1, which is at a distance R1. If it is 2, so instead of a 1, we say that this is the potential due to the charge 2, and this is Q2, and this is 2. So these are the potentials due to the charge 1, charge 2, and etc. So as a resultant, we say that the potential is equal to 1 upon 4 pi epsilon naught, which is the common factor in each potential. This factor, which is 1 upon 4 pi epsilon naught, is the common factor which can be taken out from the equation. So this is V1 is due to the charge Q1, which is at a distance R1. This is V2, which is due to the charge Q2 at a distance R2. This is V3, which is due to the charge Q3 at a distance R3. So and so on up to this. This is due to the Qn at a distance Rn. So here this V can be written as 1 upon 4 pi epsilon naught sum of all charges, which varies from I is equal to varies from 1 to n, because total number of charges is equal to n. The potential is equal to Qi over Ri. It means this I is the indices which varies from 1 to n. If you want to write the potential due to the first charge, you can write it as a Q1 upon R1. If you write a potential due to charge Q2, Q2 upon R2, and so on. So this is the how the potential, electrical potential is to be calculated. This is what we have done in the last lecture. I just repeated it to recall your memory. Now what we are doing, the electrical potential due to the dipole of the charges. So now we are discussing the electric potential due to the dipole charges. I wanted to remove it. So here, So now we are discussing what is the electric dipole, electric potential due to dipole. So dipole is simply the two polarity charges which are separated by a small displacement. Here, let's say this is two charges, plus charge and minus charge, which are separated by a small displacement, is known as a dipole. So here, this is the negative charge and this is the positive charge, which are separated by a small displacement. This displacement we call it as a d, and this d is so small as compared to the size of the atom. It means, let's say it is a dipole of the NaCl crystal. You know that Na is positive, Cl is negative. So the separation between Na atom and Cl atom is approximately in the dimensions of the atom, which is approximately is equal to the angstrom, few angstrom, whatsoever the value is. So this separation is very, very small as compared to the atomic dimension size. कि वो 10⁻⁻10 भी हो सकता है, 10⁻⁹ भी हो सकता है, etc. Means within the dimensions of the atom. So now we want to calculate the electric potential at any point P due to this dipole. A dipole is the two opposite polarity charges which are separated by a small displacement d. Let's say this point P is situated at a distance r1 from the positive charge and at a distance r2 from the negative charge. R2 from the negative charge. So the average distance from the center is this r. This is the r. So now if we look into the path difference between R1 and R2, so if we draw a perpendicular from here, so this is the path difference. This, if we compare this, this is equal, and this amount is the path difference between R1 and R2. So this path difference, R2 is larger, so path difference is R2 minus R1. If we look here, this is the angle theta. If we say that this is the angle theta, so this angle theta is, we call it as a d cos of angle theta is equal to R2 minus R1. Because this is the horizontal component, this is the horizontal component, this gives you the triangle. This component is the d sine theta, which is d into the component perpendicular to the angle is the sine component, and the component which is parallel to the angle is the cos component. So this d cos theta is equal to R2 minus R1. So now again, if we look here, d cos theta is equal to R2 minus R1. We have to calculate the potential at a point P. This charge is the charge Q, this charge is the charge Q. This is positive charge, this is negative charge. So what is the potential at a point P? We say that the potential at a point P is equal to the potential due to the positive charge plus potential due to the negative charge. And the potential due to the positive charge is equal to 1/4 pi epsilon naught Q upon R, and this R is actually R1. And potential due to the negative charge is equal to the plus 1/4 pi epsilon naught Q upon R2. So 1 upon 4 pi epsilon naught is common. This is negative charge, so therefore this is minus. So therefore it is 1 upon 4 pi epsilon naught. This is q is common, which can be taken out. So this is 1 upon r1 minus 1 upon r2. So this can be written as q upon 4 pi epsilon naught r1 r2. So this is r2 minus r1. So this is r2 minus r1. This is q upon 4 pi epsilon naught. This r2 minus r1 is equal to d cos of angle theta upon r1 into r2. So this is the potential at a point P due to the positive and negative charges. So here we have seen that R1 into R2 is approximately equal to R, which is equal to R square, and R2 minus R1 is equal to D cos of angle theta. So therefore this V is equal to 1 upon 4 pi epsilon naught D cos of angle theta upon R square. Because R1 and R2 is approximately equal to R, and which is the product gives you R square. So now we have to look this. So this can be written as, I am rewriting over there. This can be written as V is equal to 1 upon 4 pi epsilon naught. This is Q. This is Q d cos theta, Q d cos theta upon R square. This is Q d cos theta upon R square, 1 upon 4 pi epsilon naught हमने इक्वेशन से बाहर निकाल दिया। तो यहां से अगर आप ये देखें कि this V is equal to 1 upon 4 pi epsilon naught. This Q into D is equal to Q dot D. अगर Q और D के दरमियान एंगल 0 है तो ये 1 हो जाता है, तो this is called P, which is the dipole dot unit vector, P dot R upon R square. So here the unit vector whose magnitude is 1, so as a general this can be written as, here the V is equal to 1 upon 4 pi epsilon naught P upon R square. So this is the potential due to the dipole, and P is known as an electrical dipole, which is the product of the charge and the separation between the charges. Electrical dipole P is the product of the charge, any charge multiplied by the separation. And this P is known as electric dipole. This is called electric dipole. So this is what we have done. So now here, if we look here, okay, the electrical dipole is equal to P dot R. So here P dot D. P dot R over R square. यहाँ पे this can be written as P vector dot R vector divided by R cube. Divided by R cube. क्योंकि unit vector बराबर होता है vector divided by magnitude. So the vector, unit vector R is equal to vector divided by the magnitude. So unit vector को मैंने multiply कर दिया, तो as a resultant यहाँ पे आपको equation मिल जाती है. So this indicates that the electrical potential varies with 1 over R cube. R अगर आप खत्म कर लें तो it varies with 1 over R square. So this is the electric potential due to the dipole. This is one of the application of the electrical potential. अब दूसरी जो इक्वेशन है उस पे आते हैं हम.